Hello, everyone, and welcome to the ASME's A Day in a Life webinar series brought to you by Engineers for Engineers. I'm Rani Haroun and your host for today's webinar. First, I hope you're all staying safe wherever you are. And for those that are attending our event for the first time, what is the purpose of this webinar, and what is a day in the life webinar series all about? Well, you probably wondered at some point what a day in the life of a mechanical engineer working at top companies like Tesla, SpaceX, NASA would be like. Now you have the chance to find out through this interactive webinar series. In a minute or two, I'll introduce our special guest speaker of today, but first let me tell you how this webinar will work. Starting with some housekeeping, all webinar participants are signed in listen mode only. So please type in any questions you might have in the dialog box on the webinar platform anytime during the webinar. All questions will be answered after the introduction of our guest speaker. In fact, the Q&A session will be an integral part of this webinar. You may ask any kind of questions, whether it's related to the mechanical engineering field, the company, the industry, career-related questions, or any questions related to the speaker's job or position. So for those of you who are not familiar with how YouTube Live works, this is where you can type in your questions. Simply type them into the chat box in your YouTube control panel as shown here. We'll probably get a lot of questions, so we'll do our best to answer as many as we can. So let's get started and introduce you to our guest speaker. Please meet Laura Armitage, a mechanical engineer at Northrop Grumman. Laura, thank you so much for being with us today. We're very excited to have you. So at this point, can we start with you introducing yourself and telling us your story? So I'm just going to stop my presentation here, Laura, and I'm going to ask you to start your video, and hopefully you can still hear me. Yeah, you're good? Thank you.
Good. Hi, everyone. So I am a mechanical engineer at Northrop Grumman. I'm about to finish up my third year at Northrop, and my career is currently only at Northrop. I graduated from NYU in 2018 with a degree in mechanical engineering and a minor in aerospace engineering. I've supported both our aeronautics and our space sectors. So I've worked on aircraft, and now I'm working on satellites, and I've participated in our 3-year-long professional development rotation program called Pathways. So every year at Northrop, I've taken on a new role to expand like my knowledge of the business and try and figure out like the best fit for me in my career. So I'm really excited to be here and to meet all of you and to hopefully answer your questions and give you guys some more insight into what it's like being an engineer at Northrop. And if working in aerospace is something you guys are interested in, or if you need some more insight to that, because it's a very niche industry and there isn't a lot of people to reach out to.
Thank you, Laura. So while we're waiting for questions, let me actually with the first one here that we often get, and that's actually one of the main topic of this this webinar. So let's start with what does your typical day look like at Northrop?
So now I work in, so I should probably elaborate. I do not do design at Northrop. I work in our production. So I work in our MEO department, which stands for Manufacturing Engineering Operations. So I've predominantly in my 3 years worked in the production environment at Northrop. It's something that I thrive in. I love optimization. I love getting our product out the door. I believe that you can design all day, but if you can't have a working product, like your customer wants something they can use, then you can't add value to your customers. So this is the space I take up in this company. I currently am a process planner slash project manufacturing engineer. So day to day, I work in our electronics and antennas department for our satellites, and I basically get given a drawing package of an antenna that we are looking to build, and then from there, consult with our design engineers on what their thought process is about like designing how they want to put it together, consult for producibility, verify that we have all of our testing in there, and then from there, break down to our piece parts and our processes, and figure out how we're going to build our unit together. So usually an antenna comes with multiple drawing packages within it. We have a like DC harness drawing package with thermal components that get attached to it. We also have a bunch of RF cables. We have electronic active and passive like filters that go into these units, and a few other structural components, and then that pretty much makes up most of what we do. And then from there, I basically break down to our piece parts and assess what order we're going to build things in. So I go consult our technicians on the floor. We have a lot of ESD is electrostatic discharge sensitive hardware, and we have EESD, which stands for extremely electrostatic discharge hardware, sensitive hardware. And so I basically have to assess all of these requirements if we're going to torque per specific specification, or if we need to do certain resistance testing to maintain performance throughout production, and basically day to day get that done. That's within my process planning role, and then I'm growing into a project manufacturing engineering role. So from there, I start using that knowledge I've developed as planning in the order we're going to put our units together, and then now take into consideration if we have long lead times for some parts, or if we get like delivered some defective hardware that's going to change how we're going to build our flow, and do a little bit of designing tooling, or not necessarily designing, but assessing if tooling is necessary, figuring out where on our campus we're going to build certain pieces of hardware. For example, if I need to get something machined, I have to figure out like which machine shop has capacity to get our parts or tools machined, and doing a little bit of like hardware pushing, making sure everyone has what they need, and then dealing with if we have any discrepant hardware as we're building. For example, if something gets scratched, we usually have to like have a whole process, because we take quality very seriously at Northrop Grumman. So it's a very long, extensive, and tedious process, but it's for us to develop great hardware for our customers.
Great. What do you like the most about your job?
So from like two different perspectives, what I like most, and I think has influenced my opinion the most about Northrop, is my first year I worked in aircraft. I worked on our Global Hawk, which is within the HALE enterprise, which stands for High Altitude Long Endurance. It's basically a low orbiting satellite. And the benefits to that, as opposed to satellites, is satellites as Earth turns, you get a certain window over a certain area if you're trying to obtain some information, whereas with the Global Hawk, you can fly the air vehicle over a certain area for a long period of time, so you can gain intel like for a significantly longer period of time than a regular Earth orbiting satellite. While I was up in Palmdale,